So the high-technic sensor MUX and the high-technic touch MUX. The sensor multiplexer provides an independent power supply for your sensors, so that can be good because they won't be affected from power draws from other parts of your robot. It also just adds more sensors. You can turn one port on the NXT into 4 sensor ports. And for the touch multiplexer, it doesn't have its own separate power supply, and it can only be used for touch sensors, but it can also be used as sort of an extension to get to the other touch sensors. So on our Ring It Up robot, we have that on our lip for the 2 touch sensors for detecting weighted rings. The cable is so long that we have one of the longest NXT cables then plugged into the touch MUX than the 2 coming out of that.
So going hand in hand with SMUXes and MUXes these are sensors, so more for rookie teams. This is the list of all the NXT sensors. So gyroscope sensor, we use this to tell our heading during the autonomous period. So if you saw in that scouting video earlier, how our robot got knocked off course but eventually corrected and moved back onto the ramp, that was done using a gyro sensor in combination with other sensors because it knew it would be angled in the right direction. The IR seeker, this is for almost is it every year or almost every year? Most years, they're part of the autonomous challenge. There will be an IR beacon that you need to find, and in some way related to that, you can score more points. So that's one you will highly likely you'll be using. Light sensor, this is also a really common one. Most FTC fields have some change in color from the regular gray matte. So like lines or something that you can use light sensors to line up on. Accelerometer, I don't know if we've ever used this. I think we used it during the Get Over It season. This basically just tells how fast your accelerator is. So. Angle sensor, this, what we use the angle sensor for is, so you have your encoders, which you put on your motors. But what we've done is we put an angle sensor on a non-powered wheel on the underside of our robot. We call it an odometry wheel. And what this lets us do is even if our wheels skip, if we encounter something heavy, like another robot, that middle wheel, center wheel won't move, so we'll always know where we are. So for example, if we hit another robot and we push and our wheels start spinning, it'll keep trying until it reaches that location, even though the encoders think that they're traveling farther, because that wheel, the non-powered wheel, is still sitting there.
Where else do you usually use an angle sensor?
We usually use it on shoulders or arms of our robots. So on that robot over there, for the block scoop, it reads the angle that the shoulder is at. Then aside from angle, there's a color sensor. You can use this in the same way as a light sensor, but this one actually tells the difference in color rather than just the amount of reflected light. Ultrasonic sensor is used for distance, so that's just to tell how far away you're from something. We don't usually use this, but you can use it in autonomous to kind of detect another robot's coming towards you if you're running a wall. EOPD is something else used for distance. And then encoders and thermal motor cables. So these are some more miscellaneous things. Encoders, like we said, are used to measure distance. They're put on the motors of your robot. So these are more accurate than time-based movement, because the problem with time-based movement, if you encounter something that slows you down, that means you're probably not going to reach your end destination because it's how long it takes. While distance-based, it'll go the distance and get where it needs to. So thermal cables, how many of you guys have heard of thermal cables or used them? Okay. So basically thermal cables are something that the idea is it'll prevent your motors from burning and stalling because it'll cut it's like a fuse kind of. But the problem is every time it trips, the threshold for failure is increased. So it's like a vicious cycle. If it happens enough, eventually the wire is going to become unusable because it'll almost immediately trip. You're sending current through it. So we only use this for testing when we want to make sure we don't burn out a motor. For actual competition, though, we won't use it.
We try to use as many things as possible to prototype. So if you look at the picture, like there are pencils in that one. Don't limit yourself to being really professional with your prototyping. We just kind of like throw stuff together with cardboard just to explain our ideas to people. So definitely feel free to use whatever you want to sort of explain express your design, especially in the beginning stages. For the first couple weeks after the game gets released, a lot of what we build is out of just scrap metal and plastic and pencils that we just have around the shop. So definitely use